So welcome back, Stella. I hope you are doing well. Today we are going to do an exercise. This exercise, what is it? We are going to prove that this integral, the integral of 1 all over sine x plus cos x dx is equals to 1 all over root 2 ln of the absolute value of sec x minus pi on 4 plus tan x plus pi on 4. Okay, this integral, there are a lot of secrets I'm going to reveal to you in this exercise. This is a very important exercise. There are a lot of secrets I'll reveal to you in this exercise, and I'll show you two ways, two techniques to show this integral. So without wasting time, let's move directly to the exercise. I've already solved it, so I'll just be explaining. So our aim is part 2, question 2D. Our aim is to prove that this integral is equals to this. Is that okay? So naturally, what we do is what? We first, this will be the first method I'm showing to you, because there are two ways by which I can do this integral. I'll show you the first method, the method that we usually apply. So we are to find what? We first start by finding this primitive. Is that okay? Let me go down. So naturally, our substitution here will be what? T being equals to what? The tan of the angle which is here divided by 2. So dt will be what? D of tan x on 2. So naturally, we are going to have dt being equals to a half into 1 plus tan square x on 2 into times dx. Never forget your dx, because you are differentiating implicitly. From there, I will make my dx. My dx will be this. But remember, your t was tan x on 2. So this implies, let me go down. So this implies our dx is 2 dt all over 1 plus t squared. Now, after finding dx, we need to find sine x and cos x in terms of what? In terms of t. So let me go down. Let me go down. Let's now draw our triangle to find sine x and cos x in terms of t. So we know that our t was equals to tan x on 2. T is the same as t on 1. This is the opposite, and this is what? The adjacent. So I'll draw my right angle triangle. Wait, let me wipe something here. It's a bit dirty here. Let me wipe it and draw it back. Okay, perfect. So this is our right angle triangle, ABC. If this angle, our angle here is what? X on 2. This is x on 2. What is the side opposite to the angle x on 2? This side. So my t will be on this side, and naturally the adjacent side to this is this side. The adjacent side to this angle is this side, and so this one will be here. Naturally, our hypotenuse, according to Pythagoras, will be the square root of 1 square plus t squared, which is the square root of 1 plus t squared. After drawing our triangle, we need to find sine x and cos x. The thing is that in this triangle, the angle is x on 2. So we cannot use the triangle directly to find sine x and cos x. So here is a star I place. Sine x, what is our sine x? We need to find it. We can recall that sine nx is equals to what? 2 sine nx on 2 cos nx on 2. You understand? So this is a trigonometric identity. Now, to have sine x, I have to what? To replace n by what? 1. Everywhere that I will see n, I will replace by 1. So this implies sine x will be equals to what? 2 sine x on 2. Because if I place 1 here, I will have x on 2 cos x on 2. Now, we can already find sine x, because from the triangle we can get sine x on 2 and cos x on 2. From this triangle, my sine x on 2 is opposite all over hypotenuse, which is t all over the square root of 1 plus t squared. My cos x on 2 is equals to what? Adjacent all over hypotenuse, so which will be 1 all over the square root of 1 plus t squared. Is that okay? I'll then take this sine 2x and this cos 2x and come and replace here to have the value of sine x. So let me go to the next sheet of paper. So this is it. I'll have my sine x being equals to 2 into this times this. So my sine x is this. Is that okay? My cos x, how do I find my cos x? I cannot find cos x directly from the triangle. Is that okay? Because the triangle, in the triangle, the angle is what? X on 2. So I'll recall a trigonometric identity, first of all, that will relate a whole angle to a half angle. I know that cos nx is equals to what? 2 cos square nx divided by 2 minus 1. So for this to become cos x, I'll have to replace where I see n by what? 1. This implies cos x will be equals to what? 2 cos square x on 2 minus 1. Is that okay? We had to already find cos x on 2, which was 1 all over the square root of 1 plus t squared from the triangle. So I'll just replace it. I'll have cos x being equals to 2. I open my brackets, 1 all over the square root of 1 plus t squared, all that square minus 1. Is that okay? So let me drag this down. Wait a minute. So let me drag this down. From there, after simplifying, I'll have cos x being equals to 1 minus t squared over t, 1 plus t squared. Is that okay? I'll then find sine x plus cos x, because our integral was to find, our aim was to find the integral of dx all over sine x plus cos x. So I'll find it. After finding it, I have this expression. Now, this implies the integral of dx all over sine x plus cos x will be what? Our dx was 2 dt on 1 plus t squared, and our sine x plus cos x was what? Minus t squared plus t plus 2t plus 1 all over 1 plus t squared, which will be this. So let me drag this down. So this implies this integral will be equals to this, implying yes, this integral will be equals to 2 times this. There's a very important thing I'll say here. Remember what I'll say here, because I solved this question twice, because the first time I made an error in this exercise, and I'll give you a secret now. You should never do that error. Never do that error, or you will always have a wrong answer. Never do that error. This is the advice I'll give you. Whenever you have a quadratic expression where you have a minus in front of t squared, when I'm talking of minus, let's say you have minus 3t squared plus, let's say, 3t plus 5. When you have a quadratic expression like this, where there is a minus in front of the term in t squared, always factorize that minus. Write back the expression as 3t squared. When you factorize minus here, you have minus 3t minus 5. Always do this. That's an advice I'm giving you. I'll explain why you have to do that. I'll explain why it is very important to do this. Let's take, for example, let's say we keep this minus. Look at something. Let me go on a rough walk. Our aim, we have t squared plus 2t plus 1. Let's say you factorize it. Let's calculate first of all delta here. Delta will be equals to what? Delta will be equals to b minus 4, b square minus 4ac. Is that okay? This will be equals to what? 2 square minus 4 into what? Minus 1 into 1. So this implies our delta will be equals to 8. Is that okay? This implies our t will be equals to what? Our t will be minus b. So it is greater than 0. So this has what? 2 real and distinct roots. This implies our t will be equals to minus b plus or minus the square root of delta all over 2a. This implies t will be equals to what? Our b is 2. So I will have minus 2 plus or minus the square root of 8 all over 2 into our a was what? Minus 1. You will notice something here. This implies t will be equals to what? Minus 2 plus or minus 2 root 2 all over minus 2. So this implies t will be equals to either minus 2 plus 2 root 2 on minus 2, or t will be equals to what? Minus 2 minus 2 root 2 on minus 2. Is that okay? This implies then that t will be equals to what? T will be equals to, this is minus 2. Minus 2 divided by minus 2, this will give 1, and this will give minus root 2. Or t will be equals to what? 1 plus 2 root 2. When you reach at this level, naturally, we know that the factors will be what? T minus 1 minus root 2 into what? T minus 1 plus root 2. Is that okay? Now, let's verify something. Let's try to develop this. If that will give this, let's try to develop that. If we develop this, I will have this times this. This will give t squared. This times this, I'll have minus t into 1 plus root 2. This times this, I'll have minus t into 1 minus root 2. And naturally, this times this, the minus and the minus will become plus. And we're going to have plus. Look at something. This is a difference. It will be a product of difference of 2 squares. So I will have 1 square minus root 2 squared. Is that okay? So let's develop that. This will give t squared. This times this minus t. This times this minus root 2 t. This times this minus t. This times this will give plus root 2 t, and finally this is 1 minus 2 minus, this will give minus 1. This will be equals to what? T squared. This will go with this and we'll be left with minus 2t minus 1. What do you notice? You notice that it doesn't give us this. It doesn't give us this. So be very careful whenever there is a minus outside here. Be very careful. Be very careful whenever you have a quadratic equation and there is a minus outside here. Never you directly apply delta. Let me show you. This is how you are supposed to do. The first thing you have to do when you have a minus at the level of the term in t squared, you first factorize the minus. You are going to have t squared minus 2t plus 1. Now, what you are going to do is that you are going to factorize this. You calculate the delta of this. So delta, let's verify if t squared minus 2t plus 1 is factorizable. There is something, I can look at something. This expression is exactly what is under here. This means this thing, without even calculating delta, we know that when we will factorize this, we are going to have what? This. So I'll not waste time. So let's verify. Delta will be equals to what? B squared minus 4ac. This is our expression. This would be, what is our B? Minus 2 squared minus 4 into A1 in times C. C is 1. So this will be equals to what? No, I factorize minus here. If we factorize, this is minus. Don't do an error. So our C will be minus 1. Is that okay? So I'm going to have what? 4 plus 4. This implies our delta is equals to what? 8, which is greater than 0. So this has two real and distinct roots. Look at something. I'll not waste time calculating it using the quadratic formula, because I know already that when I develop this, I have what? This. So this our t squared minus 2t plus 1 minus 1. This is minus 1 is equals to what? I'll just copy this one. Is equals to t minus 1 minus root 2 into what? Into t minus 1 plus root 2. So we know already that this one, it can be simplified into these factors. We just come and replace it inside here. So this minus t square, this one minus t square plus 2t plus 1 will be equals to what? Minus into what? I'll copy this, t minus 1 minus root 2 into t minus 1 plus root 2. That is how you see that if you develop this, it gives you what? This. When you multiply by the minus, you have what? Minus t squared plus 2t plus 1. Exactly what is up here. So this is a very important thing, I'm telling you. When you have a quadratic expression and there is a minus outside here, never you go directly and calculate delta. Never do that error. Never do that error. First put the minus outside. You verify if this is factorizable. From there, you factorize. If this is factorizable, you factorize it and you just come and replace it here. Never do that error. This is a very important thing I'm saying. Never do that error. Okay, let's go back to our exercise. So we were at this level. So at this level, I factorize what? Minus. This minus, because my quadratic has a minus at the level of the t square. If there is no minus at the level of the t square, just calculate your delta. Just go directly without wasting time. The problem is when there is a minus at the level of the t square. Always factorize. That's why I placed minus outside here. This gave me, so when I factorize minus, I have t squared minus 2t minus 1. Is that okay? Let me go up here. From there, I'll have this integral being equals to minus 2 because there was a 2 outside here. Minus 2. So the minus which was here comes on top. All over t squared minus 2t minus 1 dt. Is that okay? Now, let's check if this under is factorizable. I calculate delta. After calculating delta, I saw that my delta is equals to 8, which is greater than 0. So t squared minus 2t minus 1 is factorizable. I then calculate my t. From the quadratic formula, my t will be minus b plus or minus root b, root delta all over 2a. Is that okay? From there, I'll have t being equals to minus, there's a minus outside. Our b is minus 2 plus or minus root 8 all over 2 into our a is 1. So from there, we have t being equals to this or t being equals to this. We have t being equals to this or t being equals to this. I'll then have this integral being equals to what? The integral of minus 2 dt all over what? I'll bring this on the other side and this on the other side. This gives me these two factors. Is that okay? Take note of this minus I told you. Take note of this approach I'm using. If you just try to do an error and work directly with this minus, you have a false answer. Take note of that. This is a very important exercise. There are a lot of tricks I'll give in this exercise. So from here, we have this. Now, since the degree of this numerator, this minus 2, is less than the degree of the product of this, we have to express what? These impartial fractions. So this is a linear factor. This impartial fraction will be a all over this plus b all over this. So I'll copy back this. Naturally, the LCM here has to be the same thing as here. So this divided by this, I'll have a into, because this is t minus 1 plus root 2. So I'll have a into times this one. So this divided by this, I'll have b into this one. Is that okay? From there, so let me continue. Since this is identical to this and the denominator is already equals to the denominator, it means the numerator here has to be identical to this. So that's why I wrote minus 2 being identical to this plus this. Now, we find the zeros of this. The zero of this is 1 minus root 2, and the zero of this is 1 plus root 2. When t equals to 1 minus root 2, this term will become 0. And I'll substitute where I see t here, 1 minus root 2. From there, I'll have b being equals to 1 all over root 2. Is that okay? Okay, let me go on the next page. We do the same thing for when t equals to 1 plus root 2, I'll have minus 2 being equals to a into, I'll substitute, let me go back here. I'll substitute here when t equals to 1 plus root 2. When I substitute it here, this becomes 0, and I'll also substitute 1 plus root 2 here. So on this side, I'll have minus 2 being equals to this. From there, I have my a being equals to minus 1 over 2. Is that okay? So, wait, let us continue. Now, this implies this will be identical to what in partial fraction? Our a was minus 1 over 2, minus 1 over 2 over this, plus b was 1 over 2 all over this. So this implies this minus 2 on this will be identical to what? I'll factorize, look at something. This root 2 will go under. So there will be 1 on root 2. This root 2 will also go under. 1 on root 2 will be common. Is that okay? So I will factorize 1 on root 2, and I will have 1 all over t minus 1 minus root 2 minus 1 all over t minus 1 plus root 2. Is that okay? So from there, the integral of this will be equals to what? I'll bring the integral inside here. So 1 all over root 2 integral of this minus integral of this. Is that okay? Don't forget that the root 1 on root 2 multiply all of this. From there, this is a linear expression. It's like you are integrating 1 all over ax plus b, which is what? 1 all over ax plus b prime ln of the absolute value of ax plus b plus a constant k. When I differentiate, now this is prime, so you have to differentiate this. We know that the integral of this will be 1 all over this prime ln of the absolute value of this. But when we differentiate this, that gives 1. Is that okay? So that's why I wrote this. The same thing here. Is that okay? Minus this. Now, let me continue. Now, this is the same thing as ln A minus ln B. So this will be ln of what? This all over this. Is that okay? And since absolute value of A all over absolute value of B is the same as absolute value of A on B, that's why I have what? This. Don't forget there is plus a constant of integration here with k belonging to R. This plus k is for this one because we have already integrated here. Now I'll have 1 all over root 2 ln of this plus k. Is that okay? But remember, our t was tan x on 2. Is that okay? Let me wipe this. Let me wipe this. But remember, our our t was what? Our t was tan x on 2. Is that okay? So where I see t, I will replace. Look at something. This, where is this t minus 1 coming? Look at this. T minus, this minus will affect this one. It becomes t minus 1. Is that okay? This minus affect this. This becomes plus root 2. Is that okay? The same thing here. T minus 1. I put it here. This minus affect this plus root 2, and it becomes minus root 2. Is that okay? So where I see t, I replace by time x on 2. Let me go up. So this integral becomes ln of the absolute value of what? Tan x on 2 minus 1 plus root 2 in all over tan x on 2 minus 1 minus root 2. Now, this is where this is the answer we had. It's a correct answer, k belonging to R. But the problem is that this is the question they want us to prove. This is the exercise they want us to prove. They want us to prove that this integral is equals to this. So this means that our next step, so we are to prove that what? the integral of dx all over sine x plus cos x is equals to what? Ln of the absolute value of sec x minus pi on 4 plus tan x minus pi on 4 plus a constant k. So this is our answer. Our answer does not resemble this. So what we have to prove is, oh, don't forget there is one on root 2 outside here. Then we have also a 1 on root 2. Look at something. There's 1 on root 2 outside here. I forgot it. There's 1 on root 2 here. Don't forget it. Now, there's 1 on root 2 outside here. There's 1 on root 2 outside here. So for this expression to be equals to this, there is ln here, there is ln here, there is the absolute value. For this expression to be equals to this, we just need to prove that what? We need to prove that the absolute value of tan of x on 2 minus 1 plus root 2 all over tan of x on 2 minus 1 plus root 2, we need to prove that this absolute value is equals to what? The absolute value of sec x minus pi on 4 plus tan x minus pi on 4. If we prove that this absolute value is equals to this absolute value, then we will have proved that this integral is equals to this integral, because there is 1 on root 2 here, there is 1 on root 2, there is ln. So we just need to verify that this absolute value is equals to this absolute value. Look at how I'm going to prove it. I'm going to show you another way of proving these things. We shall prove them in terms of t's. Look at what we shall do. Let me go to the solution I did. Let me go to it. Okay. So remember that in this, our final expression here was what? Our final expression here in terms of t was 1 on root 2 ln of this plus k. So we simply need to prove that this, so this, which is the same thing as this, must be equals to what? This. Is that okay? Because if we replace this tan x on 2 by t, is simply t minus 1. Is that okay? So this is our proof. We need to prove that t minus 1 plus root 2, the absolute value of t minus 1 plus root 2 all over t minus 1 minus root 2, which is the same thing as, in terms of tan x on 2 minus 1 plus root 2 in all over tan x on 2 minus 1 minus root 2, absolute value, must be equals to this. What I will do is what? It's very difficult to leave from here to here. So what I will do is what? Logically, that's what I can see. I think you can also see that would, if you want to leave from here to here, it will be very difficult, because for you to leave here, you would need to find a lot. You need to think a lot to transform this in order to bring out this pi on 4. So that will take a lot of time. So what I will do is that I'll instead try to leave from here to here. Is that okay? Now, this is what I'll do. Take note of this. This, I'll first calculate sine this plus sec this plus tan this. After that, I'll apply the absolute value. Is that okay? We know that sec of this plus tan of this is equals to 1. Sec is the same as 1 on cos. So this will be 1 all over cos this plus sine x, because this is tan, sine x minus pi on 4 over cos x minus pi on 4. This is the same denominator. So I'll add this plus this. I'll have this. Is that okay? From there, I'll expand this. I know that sine a minus b is equals to what? Sine a minus b is equals to, let me put the plus here. Let me give you the general formula. Sine a plus or minus sine b is equals to sine a. Let me write the answer down here. Is equals to what? Is equals, let me write this. is equals to sine A cos B. You keep the same signs, plus, no, the sign does not change, minus plus, because here was minus plus, I place the minus on top. Now this on the other side, it will be cos A sine B. Is that okay? But for the formula of cos A plus, let's say plus or minus B, the formula is what? Cos A cos B. The sign now changes, minus here and plus under, sine A sine B. Is that okay? Now let's apply these formulas, these two formulas. So we have to expand sine x minus pi on 4. We're going to use this formula. So this becomes, on top I'll have 1 plus sine x cos pi on 4 minus cos x sine pi on 4. Is that okay? On top I'll use what? On top we have on the bottom we have cos x minus pi on 4. So I'll use where there is the minus. So this becomes cos x cos pi on 4 plus sine x sine pi on 4. Is that okay? Now let's continue. I know that cos pi on 4 is 1 all over root 2, which is the same thing as root 2 on 2. But I will decide to work with 1 all over root 2 on 2. So this gives me 1 over root 2 on 2 sine x minus this sine pi on 4 is the same thing as it's 45 degrees, so 1 all over root 2 also. The same thing here, cos pi on 4, 1 all over root 2, sine pi on 4, 1 all over root 2. Is that okay? Now, at this level, this is the same as 1 plus sine x all over root 2 minus cos x all over root 2. You see that this and this have the same denominator. I'll have 1 plus what? Sine x minus cos x all over root 2. Is that okay? This root 2 will multiply. I'll have root 2 plus sine x minus cos x all over root 2. The same thing here under, I'll have what? I'm going to have, I'll have here, I'll have cos x plus sine x all over root 2. So you see that this divided by this, the root 2, the root 2 will go. So that's why I'm left with what? Root 2 plus sine x minus cos x all over what? Cos x plus sine x. Now, look at another approach I'm going to show you. The thing is that if I'm to transform this into half angles, it will take us a lot of time for us to leave from here to this. Let me show you. For us to leave from there where I show you into this. So what I'll do is what? I'll make everything possible for this. Let me show you. I'll do everything possible for this. I'll convert this expression in terms of t. I'll convert this expression in terms of t, and I will prove that it is equal to this, because I know that this is this. So if I'm capable of transforming this expression in terms of t, and I prove that it is equal to this, I will have proven this. Is that okay? So that's what I will do. Let's go down. So we are at this level. Remember that when we were doing the integration, I said that, but recall that when our t was equals to tan x on 2, when we're doing the integral, our substitution was what? T being equals to tan x on 2. And when our t was equals to tan x of 2, what was our sine x? Our sine x was what? 2t on 1 plus t squared, and our cos x was what? 1 minus t squared all over 1 plus t squared. Is that okay? I'll then take this cos x in terms of t and this sine x in terms of t and come and substitute it here. So that will give me what? I'll have 1 plus, let me see something. Wait. Oh, I didn't. Wait, let's see something. Oh, there is an error here. I copied. There's no root. Oh, let me wait a minute. Why is it disturbing even? So I did an error here. Let me wipe this. There's no root 2 here. Let me wipe this. So our expression is what is on top here. Let me wipe this. Our expression is what is on top here. Let me wipe that. So 1 plus sine x minus cos x all over cos x plus sine x. Is that okay? Let me see something. Oh, don't forget there is root 2 here. Yes, root 2. There is root 2. This is our expression. Is that okay? Now, I'll replace sine x. My sine x is what? 2t on 1 plus t squared. I replace it. I replace my cos x, which is 1 minus t squared over t squared. I also replace cos x here by this and sine x by this. When this and this have the same denominator, so you are going to combine them. You are going to have what? 2t minus 1 plus t squared all over what? 1 plus t squared. Now, this, so now you have root 2 plus this. This will multiply this, and we're going to have root 2 into 1 plus t squared. Is that okay? Plus 2t minus 1 plus t squared all over what? 1 plus t squared. Is that okay? So the same thing, when you simplify, this and this have the same denominator, so you are going to add this. So you see that at the denominator here, you are going to have 1 plus t squared. This 1 plus, when this will be divided by this 1 plus t squared will go. Is that okay? Is that okay? So I hope you understand what I did. So let me wipe this. Let me wipe this. So that's why when the 1 plus t squared goes, I'm going to be left with what? Root 2 into 1 plus t squared plus 2t minus 1 plus t squared all over this. Is that okay? Now, I'll rearrange things very well. I'll bring terms in t squares together. So here I have root 2 plus t squared. So I'll develop this and group terms in t squared. So this I'll have root 2t squared. There is t squared here. I group it plus 2t. There is root 2 here minus this one. Is that okay? Now, this will be this. Is that okay? Perfect. Reaching this level, let me drag this down. Okay, at this level, I'll factorize, I'll make t squared the subject here. So I'll have this plus this all over this. So you see that this is root 2 minus 1. So you see that you have a quadratic expression here and you have a quadratic expression here. Our main problem now here is to show that this expression will simplify down to this. Is that okay? How are we going to do that? It's very simple. This is a quadratic expression. My aim is to see if this is factorizable, and I'll factorize it. So, but this top, remember that we had already factorized something of this form previously. Is that okay? So I factorize the minus here. That's the technique I taught you. I factorize the minus here and I have this. But remember, in previous exercises, after factorizing this, what did we have? We had, let's go back. Let me go back on the slide. We saw previously that this, where is it even? This thing was equals to what? When we factorize it, it is equals to these two products. So there is no need, I'll not waste time, I'll just recall. Is that okay? So let me go back. So I know that, recall that this is equals to this. Is that okay? Is that okay? So I'll group this is equals to this. This minus will come in and I'll have t minus 1 minus root 2 minus root 2, because the minus will affect this. And this minus this, I'll have t minus 1 plus root 2, because the minus will affect this minus root 2. Is that okay? So now we have this expression that is our expression which is on top here, is equals to what? There is my minus outside here. I told you when you have a minus out in front of the term in t square, always factorize it first before factorizing. Never do the error to start factorizing without putting the minus outside first. Is that okay? So this expression is equals to this. Now, our main aim is to what? Factorize also this top. Let's verify if this top is factorizable. Let's verify that. Let me go down. So let's check if this is factorizable, this top. I'll calculate my delta. My delta will be what? B squared minus 4AC. Our B here is what? 2. 2 squared minus 4 into what? A is root 2 plus 1 and C is what? Root 2 minus 1. So you see that this is a difference of 2 squared. So you are going to have root 2 squared minus 1 squared. Is that okay? So that will give 2 minus 1. This is what we had here. 2 minus 1 is 1. And 4 minus 4 will be what? 0. We see that delta is equals to 0. This means that this expression, it is factorizable. And how many roots does it? How are its roots? Its roots are repeated. So we are going to find those roots. So my t, using the quadratic formula, will be minus b plus or minus the square root of delta over 2a. But remember, our delta is 0. So I'll replace 0 here. This implies this becomes, the whole of this becomes 0. So my t will be what? Minus b on 2a. Is that okay? Now, what is my b? My b is 2. I'll replace here 2. What is my a? My a is root 2 plus 1. So I'll replace here. So I'll have 2 into root 2 plus 1. Is that okay? Perfect. Let's continue. So now, this 2 will go with this 2. I'll be left with minus 1 all over. I can write back this as 1 plus root 2. Is that okay? Now, what I will do is what? This is a third. I will rationalize the third. I'll multiply top and bottom by what? The conjugate of this third, which is 1 minus root 2. So that's what I did here. Is that okay? So we're going to have 1 minus, don't forget there is a minus here. So this minus will enter here. We're going to have root 2 minus 1. Is that okay? This and this is a difference of 2 squares. So I'll have 1 square minus root 2 square, which is 1 minus 2. So this gives minus 1. The minus 1 will affect what is on top here, and we'll have t being equals to what? 1 minus the square root of 2. Is that okay? So we have already our t. We know that the root is a repeated root. So this means this quadratic expression must be equals to what? The root, if I want the factor here, I'll have, this will become t minus what? 1 minus root 2. Is that okay? That's the factor, naturally. So since it is a repeated root, so the factor will be repeated. So I'll have this all square. Is that okay? This minus will enter here. I'll have t minus 1. And this minus will affect this root 2. I'll have plus root 2. So I can already write this top as what? T minus 1 plus root 2 all that square. Is that okay? All over. This our bottom was this. We copy this. Now, what do you notice? What do you notice here? You notice that, where is it? You notice that this factor, it is the same thing here, but this one is repeated. So one of these will go with this one, and we'll be left with what? T minus 1 plus root 2 all over what? Minus into t minus 1 minus root 2. Now, don't forget that the expression we have here in terms of t is the expression of what? Sec x minus pi on 4 plus tan x minus pi on 4. Is that okay? We have not yet found the absolute value. So we are going to take the absolute value of this. The absolute value of this will be what? The will be equal to the absolute value of this. When you take the absolute value, so the absolute value of this, when we shall take the absolute value of this, it will be equal to what? The absolute value of this. Is that okay? Which is the same thing as what? The absolute value of this, which is the absolute value of this. So that's why I wrote the absolute value of this is equal to what? This absolute value, the absolute value of this. But this one simplifies to this. So it is equals to the absolute value of this. Is that okay? Don't forget, there is a minus outside here. So this absolute value will remove this minus which is outside. So this will be equals to what? Because look at something. the absolute value of A, the absolute value of A times B is equal to what? The absolute value of A times the absolute value of B. Is that okay? So we know that this absolute value, so let me show you clearly what I'm saying. Let me show clearly what I'm saying. This is what I'm saying. This absolute value, let me wipe this. Okay, this absolute value is equal to what? The absolute value of t minus 1 plus root 2 all over minus into the absolute value into t minus 1 minus root 2 is equals to what? When I apply properties of absolute value, is the absolute value of t minus 1 plus root 2 all over what? All over the absolute value of minus into t minus 1 minus root 2. Is that okay? Now, if I apply this property, absolute value of AB equals to the absolute value of A times the absolute value of B. At the bottom here, this becomes equals to what? Absolute value of t minus 1 plus root 2 all over what? Absolute value of minus 1 times the absolute value of t minus 1 minus root 2. Is that okay? Now, the absolute value of minus 1 is 1. So that's why this simplifies. So this will simplify to the absolute value of t minus 1 plus root 2 all over what? The absolute value of t minus 1 minus root 2. Now, we know that the absolute value of A all over the absolute value of B is the same as absolute value of A on B. So that's why this goes back to this. Is that okay? So let me wipe back all of this. That was just to illustrate how things came about. So this is our final answer in terms of t. So the absolute value of this in terms of t is equals to this. But what do you notice? This expression is equals to what? It is equals to exactly the expression in terms of t we wanted to prove. If you even let your t, you can even go further. If we know that our t was what? Tan x on 2. Is that okay? This is it. Our t was what? Our t, when we were doing the integral, our t was tan x on 2. So if we substitute it here, we basically see that if we substitute t equals to tan x on 2 here, we see that this absolute value is equals to this. So that's how we prove it. So the trick that you have to learn here is what? You should always remember when you want to prove something, in these integrals, always write the expression of the final integral you had in terms of t, which is identical. You write the form in terms of tan, you have in terms of the trigonometric ratio you were working with, and you equate it to what you want to prove. Now, what you will do is that you first try to write what this expression that you want to verify in terms of t. You first write it in terms of t using what? The substitutions you used previously. Is that okay? So from there, when you have your final expression in terms of t, you know that in those substitutions, your t was what? You just recall yourself. What was your t? You just take your t and you come and substitute it here, and you have proven everything. That's another technique I wanted you to remember in this exercise. So the most things you had to remember in this exercise was when you have a quadratic expression where there is a minus in terms of in front of the term in terms containing t squared, always factorize first of all the minus before proceeding. So verify if what will be left is factorizable. That's the first hint I want you to know. The second thing is you can always prove these things by transforming what you want to turn into an expression in terms of t that you will simplify, and then come back and substitute your t to have the final expression. Is that okay? From there, we have already proved that this absolute value is equals to this absolute value. So naturally, we can conclude that what? We can conclude that this integral, this integral, this integral, which is equals to this, is also equals to what? This. Because the 1 on root 2 was present here, and the ln was also present here. So we just had to prove this being equals to this. So this was a very important exercise. There is a second method I'll show you. There's a second method I'll show you how you can also go about to integrate this. In the second method, we shall have our final answer exactly this. So in the next video, because this video is already 50 minutes, in the next video, I'm going to show you how to directly prove that this integral is equals to this without having this answer, without falling on this answer. So see you in the next video where I'm going to show you the second method on how to prove this integral. See you in the next video.